Okay, so in this lesson we're going to look at complex numbers and this idea of what are called transformations. So if we have a look at this so that we're familiar with what this is, it's an Argand diagram. Now if we take the complex number, so imagine we have the complex number and we'll just write it down here. So we take a complex number, let's say 3 plus 2i. So we call this complex number z1 and the value for the complex number is equal to 3 plus 2i. 3 plus 2i. So what we can do is we can take this complex number and we can plot it on this diagram. So remember, the horizontal part represents represents the real axis, or the part where the real numbers go, and the vertical axis represents the imaginary part. So remember, this is 1i, 2i, 3i, 4i, 5i, and then this is minus 1i, minus 2, and so on. So if we take this number 3 plus 2i, what we can do is we can represent this complex number on this diagram. So you see here, so 3, we can go across to 3, there's 3 there, and then we're going up 2i. So 3 plus 2i would be plotted somewhere about here. Okay, so 3 plus 2i is somewhere about here. And we learned how the modulus then, if we wanted to get the modulus, so let's say the modulus of z1, so that's just the modulus of z1. The modulus of z1 is going to be the distance from here out to here. Okay, so so this is 3i. We'll just plot it, so 3 plus 2i. And the modulus then, if we were to draw a line from here all the way out to here, so this line from here to here will be the modulus. So that's what the modulus is. Now, when we talk about transformations, what we're doing is we want to transform this complex number and see what happens to its position, let's say, on the diagram. So let's say if we were to take this complex number 3 plus 2i, and if we were to multiply it by the real number 2. So imagine we take this complex number here and we multiply it by 2. So it'll be 2 multiplied by 3 plus 2i. So what's that going to be equal to? So you have 2 multiplied by 3, will give me 6, okay, and then 2 multiplied by plus 2i will give me plus 4i. What we have to do then is so now if we plot this, so we've basically multiplied this by 2, and now we have a new complex number. And we can see essentially what's happened is we've doubled the real part and we've doubled the imaginary part. So what we can do is we can plot this on the diagram. So it's going to be 6, so we're going across 6, and then we're going up 4. So it's going to be 6, and then we go up here to 4. So we're going to plot it here. So this is our new complex number, so it's 6 plus 4i. Now what we've noticed is that what's actually happened is the modulus has actually doubled. So if we draw this line out here, so imagine the distance from the origin out to the modulus, it's now double the distance from here to here. So essentially what's happened is we've doubled the modulus. And this here is what's known as a transformation. So we started off with this number here, we've multiplied it by 2, we've replotted our new complex number, and then this here is what's called a transformation, or we've transformed the original complex number. So, and what we've done by doing that, we've actually doubled the modulus. So this is what happens when we take a complex number and we multiply it by a real number. So essentially what we do is we actually increase the modulus. So for example, if we multiply by 2, we're doubling the modulus of the original complex number. If we, let's say if we multiply it by 3, we would increase the modulus of the new complex number by a factor of 3. And if we multiply it by 4, for example, this would be 4 times bigger the modulus. So that's what's happening essentially when we multiply a complex number by a real number. And what we want to think about is what happens to a complex number? So this is what happens when we multiply. So this is, for example, multiplication. But what would happen, let's say, if we, what happens with addition? So for example, imagine we start off with a complex number somewhere about, let's say, here, okay? So this complex number is going to be 2 plus 4i. Okay, so that's the complex number 2 plus 4i. So that's it there, okay? And if we, so what happens with addition? So let's say if I have the complex number 2 plus 4i, okay, so that's our complex number there. And let's say I was to add the complex number, let's say 2 plus 3i. Okay, so I want to add these two complex numbers together. So if I add them together, so I'm just adding the complex part. So this is going to be equal to, so 2 plus 2 is equal to 4. And then plus 4i plus 3i is just going to be equal to plus 7i. So this is our new complex number. So if we plot this new complex number on the diagram, so it's going to be across 4 and we go up 7. So across 4 up 7, so it'll end up being here. And what we notice is that we can see that there's been an increase. Let's say, so from here to here, there's been that increase. So we can draw a line like that. This increase here, okay, so we started here and we ended up here. So this is our new complex number. When we add, so we've just added the two numbers together, so it's 4 plus 7i. So this is 4 plus 7i. So this thing here is what's called it's called a translation. Okay, so that's called a translation. So that's just the word, the term that we use to describe this. So when we add, so for example, we add complex numbers, we can see this is here is what happens. So let's do the same, let's say with another complex number. So imagine we have the complex number, we'll put a complex number here. So this is 5, so this complex number here, it's 5 plus 5i. Okay, 5 plus 5i. Now what happens if we add 5 plus 5i? We add another complex number to it. So it's 5 plus 5i. So that's our complex number. And let's say if we just add the complex number plus 1 plus 1i. So we're just adding two complex numbers together here. So again, we just add the real parts. So 5 plus 1 is 6. And then plus 5 and plus 5i and plus 1i, that's going to be equal to plus 6i. So we can replot this on our diagram, 6 plus 6i. So this is where we started off, and we end up in, so it's 6 plus 6i, so it goes up to here. So this is 6 plus 6i. So we can see again, so this is our translation from here to here. And we can see that when we add complex numbers to each other, the direction of the translation is the same. So we can see it's generally in this direction, and the same with this, it's in this direction here. So we can see it's the same direction. Then is with translations that the complex numbers are moved in a given direction, a given distance, the same direction. Okay, so this moves from here to here, and this moves from here to here. So they're moving a given distance, but moving in the same direction. And that's what happens when you add, for example, complex numbers to each other. So they'll generally move, the complex number will move in a given direction, it'll move in the same, a given direction, but then, it'll move in a given distance in the same direction. So that's the way that they'll move. What I think about then is, let's say if we have a complex number, something like this. So let's say it's 0 plus, let's say, 6i. So 0 plus 6i. So this is our complex number. So we can plot this number here on the diagram. So we have, so it's 0 and then it's 6i, so it's going to be up here. Okay, so that's our complex number there. So that's 0 plus 6i, and I'll just draw an arrow. So this is 0 plus 6i. Now, what happens to this complex number? Let's say if I was to multiply it by, let's say if I was to multiply this complex number by I. So if I take this complex number and I multiply it by I. So I by 0 just gives me 0. Okay, I by plus 6i, that's going to give me plus 6i squared. And if we remember, I squared is equal to minus 1. So what will this become? This will become plus 6 times minus 1. Okay, and then 6 times minus 1, that will just be equal to minus 6. Okay, so the real part now is minus 6. And if I want to turn this in, remember, if we want to turn this into a complex number, so sorry, now just move this down a little bit. So this is what we get. So I've multiplied the complex number by I, so it leaves us with 0 plus 6i squared. I squared is minus 1, and then this will change to minus 6. And then if we want to turn this into a complex number, it'll be plus 0i. Be plus 0i like that. Now let's say if I want to plot this on our diagram, it's going to end up somewhere up here. So minus 6 plus 0i. So if we go with, so for example, the real part is minus 6. So minus 6 is over here. And then 0i is going to be here. So it's going to end up here. So this is minus 6 plus 0i. So that's the complex number. So notice that we started off up here, okay, and then when I multiply this complex number by I, you can see that there's a rotation in this direction. Okay, so we've rotated this way down to here. So basically we have done a rotation of 90 degrees. So we can see here that there's basically a rotation from here all the way down to here by 90 degrees when I multiply this by I. Now, what would happen to this number here if I was to multiply, instead of multiplying it by I, if I was to multiply it by I squared? So let's have a look and see what that would look like. So imagine this is so there we multiplied it by I, but now I want to multiply it by I squared. So I take our same number, so we have, so it's 0 plus 6i, and now I'm going to multiply by I squared. So I squared by 0 just leaves me with 0. I squared by plus 6i is this guy. So remember, we can actually before I multiply it, I squared, if we remember this rule here, I squared is equal to minus 1. So essentially what we would be doing is we're multiplying this by minus, so plus 6i. So we're multiplying this by minus 1. Okay, so minus 1 multiplied by 0 gives 0. Okay, and then minus 1 multiplied by plus 6i, that's going to give me minus 6i. So it looks something like that. So if we were then to plot this on our diagram, so 0 minus 6i. So again, we go back to our diagram here. So we have, so the real part is 0, okay, and then the imaginary part is 6i, so it ends up down here. So this is 0 minus 6i. Okay, so that's where it ends up. Okay, so we started up here, and we multiplied it by I squared, so it rotates, it actually goes a whole 180 degrees. So it rotates down. So it rotates here like so. Okay, so there's a full rotation there. Okay, and that's not a great circle, but we can see that this full rotation here, when we multiply by I squared, it actually rotates a full So that's actually 180 degrees. So we can see here, so when we multiplied it by I, it rotated 90 degrees, and we're rotating anti-clockwise. Okay, so it's rotated anti-clockwise. When we multiplied it by I squared, it rotated a full 180 degrees. It started up here, and it ends up down here. And similarly, if I was if we wanted to multiply this same number by I cubed, so let's have a look and see what that would look like. So let's multiply by I cubed. So what's that going to be? So we've I cubed multiplied by 0 plus 6i. So this here is essentially, if we think about what it is, it's I squared multiplied by I multiplied by 0 plus 6i. Okay, so, and then this I squared is just minus 1, so it's going to be minus 1 multiplied by I multiplied by 0 plus 6i. And then this will just become minus I minus 1i multiplied by 0 plus 6i. So it looks something like that. And then if we just multiply that by it, so minus 1i by 0 will just be 0. So that's going to be equal to 0. And minus 1i multiplied by plus 6i, that's just going to be equal to minus 6i squared. Minus 6i squared like that. And then I squared, remember, is equal to I squared is equal to minus 1. So that will become minus 6 multiplied by minus 1. So that's equal to minus 6 multiplied by minus 1. And then that's just going to become, it's just going to be equal to 6. Okay, and then if I want to change this into a complex number, so that's going to be 6, and then we just add 0i. That's what it's going to look like. And then if I want to plot this on my diagram, so it's 6 plus 0i. So let's go up here and have a look at this. So we've 6, 0i, it's going to be up here. So this is 6 plus 0i. What we want to do is we want to plot this, and it's going to end up here. So if we think about where we started off, so we started off up here, and we multiplied it by I cubed, and it's actually done a full rotation right the way down here, and it's ended up here. Okay, so we're talking, so let's say if we plot that on the diagram, so we're starting up here, let's say, and we're doing a full rotation all the way right around up to here. Okay, so that full rotation then all the way right around there is 270 degrees. So we've done a full rotation of 270 degrees as well. And this is what happens basically when you multiply a complex number by I. So if you multiply it by, if you take a complex number wherever it ends up, wherever it starts off on the diagram, so in our case we started up here, you multiply it by I, it rotates it anti-clockwise by 90 degrees. If you multiply the same number by I squared, it rotates it 180 degrees. So it ends up, for example, like it ends up down here. Okay, and that's 180 degrees. And then if you're to multiply by I cubed, it rotates it 270 degrees, and it'll end up here. So it's basically, you can see the position, it goes from here to here when multiplied by I, goes from here to here when multiplied by I squared, and then it goes from here to over here when it's multiplied by I cubed. Just based on that as a general rule, so let's say if we take a complex number, so remember z just represents a complex number, and if we multiply it by I, it rotates 90 degrees. Okay, if we take the same complex number and multiply it by I squared, it rotates 180 degrees. Okay, and then if we take the same number and multiply it by I cubed, it rotates by 270 degrees. So it rotates like that. So this is just important to remember. Okay, so it's just one of those rules that you need to remember in relation to complex numbers and these diagrams. And that's essentially what happens. And these are known as they're known as transformations. So hopefully that makes sense as an introduction, and we'll go through more of these in the class. That's generally what happens when you take a complex number, when you multiply it by a real number, when you add two complex numbers together, and then when you multiply a complex number by I squared or I cubed.